Okay, guys, thanks for your attempt. Let's do the corrections. Okay, so they want us to prove that the left hand side is equals to the right hand side. Remember, when you are proving, you have to start with the complicated side. You write the complicated side down first. So I'm going to say left hand side, cos I'm writing my left hand side, yeah, as it is. I'm starting with the complicated side. Something like this will come in your final exam. So you must be prepared. You must know how to do what? To prove the identity. You start with the side which is complicated. You start with the side which is complicated. Now, let me ask you, on the numerator, I'm referring to the expression on top. This one is denominator underneath. On the numerator, how many terms does the expression have? How many terms? You must be able to count the number of terms from the expression. How many terms does the expression have? 2, correct. Again, when level L. In maths, if I give you something like this, we kill it. If I say x, y, z, x times y, if I say x times y times z, and I ask you, how many terms are here? The answer should be 1. Multiplication does not differentiate terms. You cannot say 1, 2, 3. The sign that will differentiate term is addition. If I say x plus 1, it means you have got 2 terms. It's 1 is 2. Even if I say x minus y, you have 2 terms, 1 and 2. So terms are differentiated by addition and subtraction. So how many terms do we have here? You count. 1. Once you see addition, it means this is the other term now. This is the second term. Don't say 1, 2, 3. Because between sine squared x and cos squared x, it's multiplication. So this is one thing. This is one term. You must be able to count the number of terms. It's 1, 2. So you've got 2 terms. Now, on these 2 terms, check if you can be able to factorize. It's very, very important, guys, that you are able to do what? To factorize, especially when you are proving the identity. Ideas such as factorizing is going to be very, very important. So you must be able to factorize your expressions. So now, this is our first term. This is our second term. So what is the common factor? We have to factorize by taking out the highest common factor. Please, guys, don't fail proving because you did not factorize. You must know that factorizing plays a key role in math. You must factorize by taking out what? The highest common factor. So you've got 2 terms. Do they have a common factor? What is the common factor of this 1, 2? These 2 terms. What is their common factor? Yeah, I'm listening. What is the common factor? It's what? It's cos squared x. That is our common factor. Who can level labo? Mornally sine squared x. Kitam yabubit. Renally sine squared x. Le cos squared x. Obviously, the first term has got nothing to do with sine. It's cos to the exponent 4. So if we have the common factor, it has to do with what? With cos. And what is the common factor? We see that the second term, cos, has the exponent of 2. So it means the common factor of these two terms, it is cos to the exponent what? 2. Obviously, here we do have cos to the exponent 2. So you take out the common factor outside what? The bracket. Cos squared x. You open the bracket. Now the question is, what do you write inside your bracket? The sign obviously is going to be addition. Kiwanaka this addition. So what is it that I put inside what? My bracket. I'm factorizing by taking out the common factor. What is my common factor? Cos squared x. Now, how do I figure out these terms inside the bracket? One way you can do it, you can say, let me take my first term, divide it with a common factor. What happens if we take the first term, cos to the exponent 4, divide it with the common factor? What happens? What are we getting? You can even use a law of exponent. If you divide powers of the same base, you keep the base, subtract what? The exponent. So your answer is cos squared x. So you take the first term, you divide it with a common factor so that you can know what to put inside the bracket. You put what? Cos squared x. Now, let's do little bit of a check. Let us check a bit. If we take the common factor and multiply it with the first term inside the bracket, it must give you cos to the exponent 4. If you say cos squared x times cos squared x, it must give you cos to the exponent 4. Now, let's find this one. How do we get this one? Same thing. We now take the second term, divide it with what? With a common factor. What is your second term? Sine squared x times what? Cos squared x all over the common factor. You are left with sine squared x. You are left with what? Sine squared x divided by 1 plus sine x. I'm saying this again. What was important here is factorizing. Once you factorize correctly, you should be able to solve this. Make sure that you understand this part. Make sure that you understand it. Again, we factorize by doing what? By taking out the common fact. Make sure that you understand it. The rest is going to be easy. So you must first identify the number of terms. How many terms? How many terms? 1, 2. Now, do they have expression in common? Do they have a common factor? Yes, it's cos squared x. Then you write this common factor outside what? The bracket. You figure out what you put inside the bracket. I'm writing NB here. Factorize. And I'm saying, don't go, please, please, please. Don't go into math exam if you don't know how to factorize. Don't go there. Because there are a lot of expressions that we are going to factorize. Many. Now, let's continue. Is this not going to? Let's continue. Let's talk about cos squared x plus sine squared x. What do you know about cos squared x plus sine squared x? It's 1. Again, I'm proud. It is called what? A square identity. It is called what? A square identity. Cos squared x plus sine squared x. This guy in the brackets, it is called a square identity. And a reactive square identity gives us 1. This cos squared x plus sine squared x give us how much? 1. And aune papano magaringa cos squared x plus sine squared x is the same as what? Sine squared x plus cos squared x. 1, 1. It is called, this one is called commutative property of addition. When you add two guys, it does not matter which one you start with. If A plus B is 1, even B plus A is 1. When we add two numbers, it does not matter which one we start with. Again, the order does not matter. Cos squared x plus sine squared x is 1. Sine squared x plus cos squared x is also what? 1. This is a square identity. So the result is 1 here. So now I'm going to say cos squared x, bracket means multiplication. Cos squared x times 1, which is Rashalakang, cos squared x over what? 1 plus sine x. Marawana we won't check in your exam. Won't check this one. I'm lazy to say 1, then I say cos squared x times 1. Make sure that you show it's 1. We must follow. Again? So cos squared x times this one is 1. I mean cos squared x times 1 is cos squared x. I still have what? 1 plus sine x. Now check. We are working with the left hand side. Is it the same with the right hand side? Did we prove our identity? The left hand side, for now, it is not yet the same as 1 minus sine x. It is not yet clear. Actually, they are equivalent, but it's not yet clear. We still have to do some workings. We still need to prove, again. So what do we do? I think this part is bit trick. It's trick. Okay, one thing we can do, pay attention. We see that actually the right hand side is 1 minus sine x. My right hand side has got nothing to do with cos. I don't see the expression of cos there. So I can change cos squared x. I can change it. What is it going to be cos squared x when we change it? Good. 1 minus sine squared x. When you change cos squared x, it becomes what? 1 minus sine squared x all over 1 plus sine x. But guys, you must know the motive. Why do we change cos squared x? Why do we do this? Because we know that where we are going, what we want to prove has got nothing to do with what? With cos. So that is why I'm changing cos squared x. I'm saying it's what? 1 minus sine squared x. Is it making sense? Okay. Great. Let's just clarify why cos squared x is 1 minus sine squared x. We know that from the square identity, don't forget your square identity. We know that cos squared x plus sine squared x is 1. We know this. It is called what? A square identity. Now level A. Let's say we only want to know about cos squared x. What we can do from the square identity? We can take sine squared x to this side. What's going to happen? Cos squared x will be equivalent to 1 minus sine squared x. So this idea that say cos squared x is 1 minus sine squared x comes from what we call the square identity. Yes, yes, yes. Oh, sure. Okay, so they are saying, they are asking for guys who are doing physical science. You can raise your hands. They want to make copies. Are you all doing physics? Be honest with me. You are all doing physics. I get 1, 2, 3, 4, 5, 6, 7, 8. I will add 3, 4, 8, 12, 12, 12, 20. Now, back to maths. Let's come here. Actually, this expression, make sure that you practice it. There are a lot of mathematical skills which you are going to learn by just solving this problem. And I guarantee you, you are going to face some of those skills. You will need those skills actually. So let's talk about 1 minus sine squared x. Do you know that can be factorized? 1 minus sine squared x. It can be what? Factorized. Using what we call difference of two squares. You can factorize using difference of two squares. This is a very nice problem, guys. Practice it. You can factorize using what? Difference of two squares. In maths, if you have this, level it. If you have a squared minus b squared, this can be factorized. A squared minus b squared can be factorized using the difference of two squares. They are squared, a squared, b squared. So when you factorize it, you open two brackets. You say a times a will give me what? A squared. And then you say b times b will give you what? B squared. Their signs must differ. So you have factorized using what we call the difference of two squares. So this 1 minus sine squared x, you can factorize it. You can say it's what? You can open two brackets and say 1 times 1 gives me 1. 1 is the same as 1 squared. Sine x times sine x give me what? Sine squared x. The signs must differ. All over 1 plus sine x. This cancel this. We are left with what? 1 minus sine x. Therefore, the left-hand side is equal to what? The right-hand side. You have proven your identity. You have proven your identity. You can do it, guys. And level more factorize it. That's why I'm saying factorizing in maths is going to be very important. You factorized here when you were taking a common factor. Where else did you factorize? You factorized here the difference of what? Of two squares. Any question? Any question? Make sure that you write this expression well and you practice. You understand why I took certain steps. Do it when you are alone. I'm going to give you another one. For what values of x is cos to the exponent 4x plus sine squared x times cos squared x over 1 plus sine x undefined. When is this expression here undefined? For which values of x will this expression be what? Undefined. What do you think I must do, guys? For what values of x is this expression here undefined? For which values of x is this expression undefined? What are you going to do? Huh? Yes, this one, the chance of you getting this one in your exam is very high. Because as a grade 12 student, you must be able to identify when the expression is undefined. The expression is undefined if the denominator equates to 0. So we know that we will say if 1 plus sine x is equals to 0, therefore the expression is what? Undefined. The expression is undefined if the denominator equates to what? To 0. In maths, we hate dividing by 0. Because if we divide by 0, the expression will be undefined. You don't want to divide by 0 in maths. You don't want the denominator to be what? To be 0. The expression will be undefined. So that expression will be undefined if 1 plus sine x is what? 0. Now we start solving. Popular the value of x. We say sine x is equals to what? Negative 1. The expression will be what? Undefined. If sine x equals to negative 1, the expression is undefined. So now let's solve for x. You are dealing, this is more like what we call a general solution. So what do? Sine x equals to negative 1. Let's recall ideas of what? Of general solution. What do we do if we are working with general solution? Yes, sine x equals to negative 1. What do we do if we are working with general solution? What do? You must first find what? The reference angle. If you are dealing with general solution, you must first find what? The reference angle. Oh, wow. Wow. When you are dealing with general solution, you must first find what? The reference angle. So what is your reference angle? Arnya reference angle yari. Ref angle. What do? You say second function of what? 1. Wamponer. Reference angle. I did not use a negative sign. Again? When you are looking for the reference angle, don't use that negative. So what is your reference angle? Press on your calculator. Say second function of 1. What is your reference angle? It's how much? Faster, guys. I want to finish. It's 90. Yeah, it's 90. It's 90. So my reference angle is 90. Now challenge. When I was looking for the reference angle, I did not use the negative sign. Why? Because this negative sign only tells me where my angle should be. In which quadrant will my angle lie? Sign is negative in which quadrant? All students takes what? Copy. Sign is negative in which quadrant? is negative in the third quadrant and what? The fourth quadrant. So it means our angles must be in the third and also in what? In the fourth. So let's say 180, 270, 360. So if you want to find the angle in the third quadrant, what are you going to do? You are going to say 180 plus 90. So x is equals to 270 plus k times 360. So the value of x actually is 270. The value of x is 270. So whatever x is about 270, the expression will be what? Undefined. Yes, so it come to this denominator there. Just say 1 plus sine 270. I want to see how much you get. Just say 1 plus sine 270. Just say 1 plus sine 270. How much you get? 0. Wabona x ikawa 270, denominator itoba 0 again. And another denominator ikawa 0. What's going to happen? The expression will be undefined. Again, the expression is undefined when the denominator is what? It's 0. Let me check your understanding. Find the value of x for which 4 over x minus 3 is undefined. Find the value of x for which 4 over x minus 3 is undefined. What is the value of x whereby 4 over x minus 3 is undefined? What will be the value of x? The value of x is 3. I said the expression is undefined. If the denominator is 0, you equate the denominator to 0. Then you solve for x. Therefore, x is how much? It's 3. So this is undefined. When x is how much? It's 3. You just take the denominator, you equate it to what? To 0. You solve for x. Then you will find the value of x for which the expression is what? Undefined. You can do it. How many minutes do I have left? How many minutes? 4 minutes. Okay. I did not solve lot of problems, but I solved only one problem which contains lot of mathematical ideas. Only one problem. But that one problem, it has got a lot of math ideas. So make sure that you understand that one problem and go and practice others. Again? Okay, let's just summarize what we have learned. Things that I don't want you to forget. Level A. Watch out factorizing. Factorizing is very important. Again? Number 2, remember your identities. Like this one. Cos squared x plus sine squared x is 1. Identities are important when you do what? When you prove that left hand side is equal to what? Right hand side. This is a square identity. Now, there are some identities that we did not use for now. Which identity didn't we use? We did not use quotient identity. That says tan, it's sine over cos. Okay, good luck. Make sure that you are studying very hard because not so long you are writing your final exam. So please work hard. Is your future concerned here? Please work hard. Do it for yourself. Good luck. See you next time. God bless you. I'm trying to see.